In this video, we're going to look at the general topic of application architecture, and in a later video, we'll apply it to Spring Boot. In general, software architecture is an abstraction of a software system that can then be implemented in many different ways. Now, the point of abstraction is to reduce complexity, and architecture also helps us to get a clean separation of responsibilities. As we do this, we are going to define component types with their various properties, relationships, and interactions. There are some advantages of having an architecture for our applications. First, there's the standardization of design, which means that all the people on a development team will have a joint understanding of how the application is put together. And this means that everybody knows where everything goes, how they interact, what the responsibilities are. And this will, over time, ensure a much better design, development, and maintenance process. A good architecture will also enhance the quality of design and implementation, and will definitely improve the ease of maintenance, and of course will provide extensibility, which is an important consideration when developing software. Some of the disadvantages of an architecture will include things like cognitive overhead, because we have to think more carefully about how to match implementation components with architectural components, and that of course will take time and effort, but it's worth it in the long run. There are also design overheads, in as much as we might want to do our own thing, but if that conflicts with the architecture that we are given, then we would be discouraged from using it. Now, this disadvantage is offset by improvements in quality, productivity, and maintainability. And allied with this is the lack of flexibility. We might want to do things in a clever way or a particularly efficient way. But if that doesn't match the architectural structure and standardization, we can be somewhat frustrated. But that standardization is a very powerful part of our work because of the improvements in efficiency of design, development, and maintenance. You might have heard of MVC, Model View Controller. This is an architecture that defines certain components within the software and allocates specific responsibilities to those components. The model is responsible for the data and the related business rules, and that is kept very separate from the view, which is responsible for presentation of the data to the user. And both of these are separate from the controller, which manages user interaction. So whenever a user request comes in, the controller receives that request and will activate one or more model components, followed by one or more view components. You might have heard of tiers and layers as well in terms of architecture. A tier is a physical separation of code in an application's architecture, and by physical I mean across different machines or processes. A layer is a logical separation of code within an architecture. So we'll probably find that a layer is within a physical tier, but might be separate in terms of components. So tiers are physical separations and layers are logical separations. In a client-server application, you might have 2, 3, or more tiers. In a 2-tier application, you'll have a client on one computer with the server and database on another computer. In 3 tiers, the database is split out from the server, and so you might well have 3 computers. Of course, each client might well be on a different computer, so you might actually end up with hundreds of different computers. When it's more than 3 tiers, we refer to it as N-tier architecture. When we combine MVC with a 2-tier architecture, we'll end up with a client-server application, 2 computers, that's the physical separation, the tiers. The server will have the controller and model components, and the client will have the view components. On the server, controllers receive requests from the client and will then activate those components that will deal with the requests. These are the model components. They will interact with the database and then send responses back to the client. And on the client, the view components will allow the user to send requests to the server and present the data that has come back from the server. In a 3-tier architecture, MVC is more readily separate in that the client will have the view components. The middle tier, the business tier, will have the controllers and the models that will process the client's requests and apply the rules for that business. And the data tier will have model components that interact with the database. Because we've got physical and logical separation of components, we need to think about what we've got and where it goes. And very often we might find flavors of MVC on each of the tiers. We need to decide how we're going to make the physical and logical separations. And having decided that, we then divide the layers across the tiers. And this can lead to other decisions, such as distribution or clustering of server-side logic. So that's a brief introduction to the concept of software architecture, and you might want to do some additional reading into some of the terms that I've just introduced, like software architecture, application tiers and layers, and server distribution or clustering.